Uh, Good evening, teacher. So we are from Group 8, and today we are presenting our project, which is called Safe Week, a modern mobile security and emergency response platform. We are using Flutter and Nest.js. My name is Sudipa, and those who are presenting with me today are Sapada Dam and Samang Alec. So let's move on to the next slide. So let's start with the problem. In emergency situation, every second account and traditional resource directly are fragmented, and website results during a panic event are often chaotic, slow, and dependent on perfect network coverage. So SafeBridge addresses this by offering a unified city shield. It provides a one-tap SIS mechanism alongside a location-based directory that geolocates nearby emergency services like hospital, like fire station, and police post instantly. So moving on to the next slide, which is about our project objectives. So our main objective are threefold. First, minimize delay, meaning user can trigger an alarm instantly with a single long press, getting rid of manual dialing. And the second is resilient. So SafeBridge must remain fully functional even if low connectivity areas through smart caching. And third is interactive GIS that enables users to find, filter, and navigate to the nearest rescue center dynamically. And now I will hand over to Alex.
For this slide, we talk about a key platform feature. The first feature is advanced GIS and OpenStreetMap integrate. Our application use photo map with OpenStreetMap to display emergency location to help user find the closest emergency service quickly. We implement the horizon distance analysis, which calculate the distance between user recent GPS location and nearby emergency center. We also provide a dynamic category filter, allow user to view only hospital, police station, fire station, or ambulance. In addition, geocoding converts GPS coordinate into readable street address, making location easier to understand. The second feature is offline resilience. Since internet access may not always be available during emergency, our application use three-layer fallback system. In first request, line data from API, and if the API unavailable, it's load a cut data stored locally. Finally, if neither is available, it's use built-in JSON data packet with the application. This ensures the app continue to work even if the internet lost. For next slide, I give to my friend.
So thank you, Alex. To achieve this, we choose a monorepo architecture that isolates the concerns of the API server and client. Our backend is built on Nest.js, utilizing type ROM for robust database queries and Postgres SQL for production. It exposes structured modular endpoints for branches, reviews, and safety guides. Our client is powered by Flutter using Provider for reactive monostate management and GoRouter for tab navigation. And so the part will now detail how we resolve coordinating geocoding.
So moving on to the next slide forward, all of our challenging. So the first one is our first technical challenge was translating the GPS coordinate into a human readable notification. So as you can see in the dot snippet, So we query the nominative API reverse geocoder, and then we pass the divide latitude and longitude, and passing the JSON response safely. And if a connection fails, we cut the exception and fall back to the coordinate string, ensuring that our UI never crash. And moving on to the next challenge, Alex will be speaking.
The challenge 2, we talk about a state management. Our application contains several types of shared data, including the user location, emergency contact, and favorite emergency center. To manage this efficiently, we use Plotter provider packet with a multiple provider. Each provider has its own responsibility. For example, location state continually update the user GPS location, contact state manage emergency contact, and favorite state store favorite emergency location. This architecture keeps our code organized and ensures that user interface automatically update whatever uh, the underlying data change. The code show on the last demonstration how all providers are initialized together when the application starts. Moving to the next challenge, Udon will talk about it.
So here, challenge three, we talk about offline resiliency. So, as a security app, safety cannot afford a single point of failure, right? So, in this code sample, we showcase our three-tier fallback string logic. On request, the app attempts to fetch live data from our Nest.js backend, and if a timeout or server exception is caught, the repository falls back to local share preferences cache. And if the cache is also empty, so it reads static JSON data embedded in the assets directory. So this ensures the client is always operational and no delay or layout vulnerability.
For challenge 4, we talk about the contact persistence. Whatever a user add or edit, delete or contact, the contact information is automatically converted into JSON format and saved locally. When the application starts again, the store JSON data is loaded and converted back to the object. This allows users to keep their customized emergency contact such as family member or neighbor even after losing the application or what there no internet connection. The code on the right along on the left show how the contacts are saved and restored automatically. That's all. Con- Certified.
I'm sorry, so let's look at the final app experience about interactive UI showcase. So on the left is our home dashboard, displaying the geocoded address with service chips and the red SOS or the blue-red SOS panic button. We use a long press gesture to avoid false trigger. And in the center here is our map view displaying the closest emergency center with path navigation link. So now let's transition to the live demo, but we will do it at the end of our presentation. Let's skip that. And let's go to the conclusion.
So to wrap up, safety successfully bridges the gap between emergency services and citizens. And by utilizing a Next.js backend Flutter client, shared preferences caches, and OpenStreetMap utility, we created a high-fidelity production-grade application that works under any conditions. And so let's move to the next slide. So this is our team member that Siddharth just told you about, and this is our task responsibility, and you teacher can stop the video and you can see our responsibility here. And now we'll move on to the last, which is to demo. But before I demo, I want to talk like our emulator is not working, so we're using a host website to host our app and demo you from there. So now I will start demo, and I will share my whole screen. So uh, can you see the screen now?
Yes, I can see it clearly.
Okay, I will demo. So as you can see, the screen before this is the flash screen. So it load every time I reload the browser. When I reload it, you can see this is the splash screen, and this is the onboarding screen when you first landing on the app or website. So we can click and we will reach the home page, and we don't our app doesn't have login, so we use the local storage to store all user data. So this is home page where we can see at the top we can see the uh, our real location, and also we can see the service uh, nearby us, and this is we can see the button where we can see and we can choose any service and we click on it. And then it will call that service in 3 seconds, and we can dismiss it or dial dispatch. And you can see here the hospital police service category, and we can click it and we can see the nearby one, but this is uh, just some of the nearby, not all. And here we can see the emergency profile where we can see upload group or location or something like that. And we can see the some of the nearest tap point. And we want if we want to see all, we can go to nearby uh, page and we can see all the nearby service that is filtered by the distance, uh, regardless of the service. And if we want to see any specific service, we can click on the category above here. We can click to the hospital, fire, or ambulance, which is the you know the van for taking the patient, and we can check also for the service that is still opening, and also we can query the service within 3 kilometers and move on to the map. This map we can see all the services in Phnom Penh, and we can also filter them from that, like police, hospital, fire, or something. And then if we click any one of that, it will show briefly the detail of that specific service, and we can call from that. And also we can change the map layout, so we can change it to classic. So it is up to your preference. If you think that the satellite one is easier for you to see, you can switch to that. So our app is more flexible on the map, and then we can go to contacts, and this is where we can add our contacts. And when we add, it is only stored in local storage. As I said, we haven't implemented the login. So if we add, let me demonstrate it. So we can add, and then we can call them directly. But I don't want to disrupt them right now. And if we clear cache or delete the app, or clear cache of the app or browser, it will clear all the data that's saved locally. And lastly, we can go to the settings, and this is where we can switch from dark mode to light mode or something, and we can change to Khmer as well. So it will translate all the pages, as you can see. It can be translated as possible, and then we can choose the plot group type. So this is the most common one. You can choose and you can type what you are uh, 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 allergic to. So for example, I can type pumpkin and I can save that. So it will save that and we can look into here and then we can see our brochure or something. And this is all uh, our app is used. So you can follow the instructions that I'm providing, and you can browse our app easily. So this is the end our presentation, and thank you, teacher, for listening and watching our video till the end. Thank you, teacher, and everyone.